moment equals to 0. So what are the moment we need to summate? First moment is created by the force FBD, correct? That's right, I want to use this. Would you mind sit nearer so that I can use the whiteboard to write? It's easier for me. But anyway, you don't need to worry about me or something. I'm just a student. Okay. Okay. So here, as we just analyzed, there will be two forces for us to analyze because we are analyzing the moment at this point C, okay, with respect to this point C. So what are the two forces? Come again. First one is the P, correct? Second one is the force BD, which is acting in the axial direction of BD. Okay? So with these two, we can set up this summation of moment equals to 0. Moment 1 will be the moment created by this created by this force P, okay, which is P times its force arm. Okay. What is its force arm? What's the force arm of P? Force arm of this force P is the distance from the point of analysis to the force. Okay. Is the distance. This must be perpendicular. That's why it's the distance. Okay, from this point to this force, which is the extension line of this force and this line. Okay, this distance must be perpendicular to the extension line of the force. That's what we mean by the force arm. Okay, so the force arm will be equivalent to the distance here. Okay, so the distance as we put down is 135 mm. Be very cautious of this unit. Okay, mm, millimeter. Second force, second moment created by this force from member BD. Okay, is this FBD times its force arm. What's the force arm of this BD? Distance from the point of analysis to the force, correct? Force is in this axial direction, so its extension line will be this line, correct? So the distance from this point to this point must be perpendicular. Okay. So this distance actually we can calculate from our given dimension. Here is 240 millimeter. So using simple geometry, we can find the angle here equals to angle here because of this triangular thing. Okay. So it's actually equals to 250 times cosine theta, which is the force arm that you require. Cos theta. Okay. Cos theta is for you to calculate here using the given dimensions, the simple geometries. This force BD is given as 500. Okay. So in the end, you can calculate your P. Okay. But you don't need to calculate now. You don't need to write down anything now, because I'm going to give you the solutions later. Okay. So I want to emphasize you again for those who didn't come late just now. In this lecture, you don't need to write anything. Okay. You don't need to spend your time copying anything. You just come here trying your best to understand. Okay. Trying to listen and understand. And also another principle I mentioned just now, to make yourself comfortable. Okay. You can do whatever you like here without disturbing anyone. Okay. Just make yourself comfortable. You can leave at whatever time you like. Okay. I will teach until the majority wants to leave. Okay. This is my So this is our first question. Okay. Here, one thing as you can memorize is the way I settle this problem. is still these 3 steps. What are the 3 steps? First thing, I analyze what are the objects inside this system. Okay, the objects are this CBA, this first object. Second object is this BD, correct? So first thing, analyze what are the objects inside here. Second thing, I draw free body diagram of these objects, of all these objects inside this system. Actually, I didn't draw, but equivalent to draw. Okay. So this CBA is the first object. Second object is this member BD. It is supposed to be, by drawing this free body diagram of BD, we know that the force is in this axial direction. So we get our very first information. Okay. So draw this free body diagram will be the second step for you. Okay. So, draw the free body diagram, including you find all the possible forces on this object. Okay. So how do we find the possible forces? By looking at the point of contact, correct? So the point of contact for this member, one is from the ground, okay? Somewhere here, yeah, we don't know, we don't care. And somewhere is from this member BD, okay? And the other one is from this force P, okay? So it's all the forces experienced by this first member. Second, for the second member, only there's a force from this D, or from this ground, okay, which is acting at this point D. The second point of contact is at this B, okay, which might act in another direction. So the last step, okay, the third step, after we find all the possible forces here, what we can do is to use back the very core information of our course here, the equations for static equilibrium. Summation of moment equals to 0 and summation of force equals to 0. Okay. So here, according to summation of moment equals to 0, we randomly pick one end as the point of analysis. Then we can deduce that the force is in the axial direction. Okay. It's the same for this one. Okay. For this one, we're also using the momentum, summation of moment. Then we decide that what will be the force at this point A. Okay. So everything we link back to these two very important equations, which are the summation of force equal to 0 and the summation of moment equals to 0. Okay. So these are the 3 steps for you to analyze a force. Okay. Analyze a force in MOM, which is the static equilibrium equations. Okay. So next question. Still, I need your collaboration to do your own practice after I give you this question. Okay? This is actually one of the tutorial questions, if I'm not mistaken. Never mind. Better that if you So as what you can see over here, this piston is inside this slot, okay, covered by this wall. And there are 2 bars here linked to this piston. So here are the joints which allows free rotation. Okay. So here, I apply a moment in this clockwise direction, this moment is of magnitude of 1.5 K Newton meter. Okay, must know the dimension. Okay, as engineers, this is as engineer sense for us to know what are the dimensions of everything. Okay, so unit is Newton meter, 1.5 K. So the question is, given these dimensions, what will be the force to balance this top? Okay, force here P.